Welcome to the course on structural analysis. So this course is offered in third year first semester civil engineering students. Although this course is also listed as open elective for final year students of other departments except civil. Because this course is basically interdisciplinary in nature, maybe some mechanical engineers, those who deal with machines and all, and some automobile or aeronautical engineers, those who design the aircraft and all, they also need to study this course. So this course deals with the behavior of structure upon the application of load. So the prerequisite for this course is engineering mechanics and the strength of material. So most probably all these basic both the basic courses, most of you have studied in your first and second year of courses, BTech course. So this course will be divided into total 5 modules, and each module will be focusing on each of the component or one of the structural method analysis to deal to find out the structural response and all. So let's start with the basic discussion or introduction to this course. So the content of this today's lecture will be historical background and the role of structural engineers and the engineering projects and the classifications of structure and the analytical model. So today we'll focus on first two content, the historical background of structural analysis and the role and responsibility as a structural engineer. When you will go to field, what will be the roles and responsibilities? So first, what do you think? Is it structural analysis a new course or maybe it is an old one? Although engineering has maybe the formal study of engineering maybe started 50 to 60 years back, but the structural analysis, all the engineering disciplines or maybe the applications of the engineering discipline was earlier there. So if you see these two structures, first one is that Egyptian pyramid and second one is Greek temple. So if you see Egyptian pyramid, it is about 3000 year BC before Christ. So if you consider, if you could calculate from today, so it will be approximately 5000 years back, we actually constructed this huge structure. So can you imagine? So this is one of the largest structure on earth today itself. So this structure is actually standing for the last 5000 years. So it has encountered so many natural calamities, but still it is standing. And similarly for Greek temples, if you see, it is 500 BC before Christ, and still the structure is standing. So you can imagine that time how they have constructed all these things without the knowledge of structural engineering. So the moral of the story is this course is not a new one. So maybe 5000 years back when the civilization started, at that time only we used to build large structures. So without the knowledge of structural engineering or maybe the physics of the structure, we can't construct these. So similarly, if you see Roman Colosseum, it is also 200 BC, still it is standing. See, can you imagine? It is very similarly for Cathedral 100,000 years AD after that. So still see the structure, spectacular structure, still it is standing. So now if we look into the modern structural engineering, so when it started. So first the notion of structural engineering was given by the Galileo. So Galileo is famous for many physical theories or physical laws he has proposed. So one of the important of his theory was this structural analysis. The basic fundamentals of structural analysis was actually developed by Galileo. So in 1564, first book he has written, that is Two New Science. Can you imagine what is this? Can you imagine? So this is a structure something, and one wooden block is laying here and some weight is there. So this calculation he did, and he calculated what could be the deflection or how much load actually this wooden block can take. So this is his first book on Two New Science. He has written first the cantilever. The notion of cantilever beam was first coined or introduced by the Galileo, and 500 years back from now onwards. So next after Galileo, Robert Hooke, he has now taken forward the Galileo's concept, and he proposed Hooke's law. I think many of you have already studied this Hooke's law in your 10th, 12th standard. Even in the first and second year of engineering also you have studied this to Hooke's law, that is stress is proportional to strain and an elastic regime. So this was proposed maybe at 400 year back from now, and still nowadays also we are using the same equation, same formula. And when you go further you will see all the analysis and everything whatever we do in the structural analysis actually lies the fundament of Hooke laws we use. Then in next after Hooke's Robert Hooke's we have the Sir Isaac Newton. So what he has coined, any guess? Yeah, so basically all the Newton's third law, three laws, all actually he has stated in maybe for 350 years back. So one of the important thing which we need in structural analysis is obviously Newton's third law, that is which is more famous. So obviously stress, every action has its equal, opposite and equal reaction. So basically this third one will use extensively in the structural analysis. Even in the second law also will use F equal to mass into force equal to mass into acceleration. That also second law also will use substantially. Then we have Leonard Euler. Euler also given is the Euler's law. Maybe you have studied in the first semester mechanics Euler's law. Anyway, we'll also we'll go through the Euler's law once again for your clarification. Similarly, 1736, C.A. de Coulomb, he has proposed the law, Coulomb's law. So Coulomb's law basically deals with the stress and strain. Stress basically the stress distribution in a structure is proposed. So still we use the same equation, same formula. So can you imagine 200 years back, or these legends have given the equation, and still we are using that. Similarly, for J.C. Maxwell's rule, Maxwell's reciprocal theorem, and all will use in this course as well. Similarly, for Moore, I think you have heard of his name. So Moore's law also will use for the stress analysis and all. Similarly, for the Castigliano, Albert Castigliano, 1847 to 1884, 150 year back. He has given many important laws in structural engineering. Castigliano's law is famous for calculation of deflection of structure and all. So we'll see all these principles and laws one by one, and we'll solve a couple of problems in this course as well. Then, and G.A. Manny in 1888, he and the Hardicross, 1885. So these two scientists are actually laid the foundation stone of modern structural analysis. So nowadays we use a lot of computer things. So earlier whatever laws was given, Coulomb's law or Maxwell's law, Moore's law, Castigliano's theorem. So all these theorems and laws are actually solved manually by hand weaves to before computer came. But once computer came, our computational energy and effort, everything increased exponentially. So now we can very quickly compute a very large structure in just a single click. So earlier all the elements in a structure analysis was done manually. So maybe one column like that, it will go on entire structure. But the modern structure analysis, we use a lot of software tools to analyze the structure. So this matrix method, we call it. So matrix method of structural analysis basically coined by them, and after that these are the scientists actually developed this this matrix method of analysis extensively, and now we are in a position to do the structural analysis in a single click. So now, so today's last topic we'll discuss about the role and the role of structural analysis in the structural engineering project. So if you see many structural, so before starting any project, any civil engineering project, so these are the basic steps are followed. So at the very beginning we have the planning phase. So in the planning phase, the government higher officials actually plan, and they order for the survey. I think civil students already started the survey. So different using different survey methods. First, you survey the entire area. Then you have the preliminary design. So now once we have surveyed the entire area, and now we can guess, maybe based on our past design or past experience, will make our preliminary design here. Structural design means to identify the length, width, everything, size of the column, length of the column, width of the beam, and then how many reinforcements, the rods and all required. So all these things, some preliminary design will do based on our past experience. Then we'll do estimation of loads. So our structure is actually made to withstand the loads. So we'll estimate the loads, and then we'll do our structure analysis. So in a given load, whether our structure will be sustained or not. So that is the outcome of structure analysis we'll do. If our structure is safe, if it is safe, then it's great. We'll go to that construction phase. If no, then again we'll redesign, restructural design will be done, and again then estimation loads will happen, and again structural analysis will do. So that this process will be basically iterative process. As long as we satisfy these conditions, this process will go and continues. So these are the basic flow chart of any structural engineering project. Today we have discussed the basics of this introduction of this course, and some starting with the historical background, how structural analysis is developed from early centuries, last 2 centuries, extensive development happened in this field, and how the modern era, how we actually do the structural analysis with the help of computers and so all the history today we go through, and then we in the last step we have seen what is the flow chart as a structural engineer, what are the roles and responsibilities you have to perform. So that's all for today. Tomorrow we'll discuss about the classifications of structure.